In this video, we are going to look at what we're going to be investigating here in Investigation 3 in our main focus. It's going to be on this thing called inverse variation. And our problem for 3.1 is we're going to be looking at rectangles with fixed area. And with this problem right here, if you haven't read it already, go ahead and take a minute and read it. And this problem is all about these homesteaders who go and purchase land, and they can purchase land at 21,780 square feet. Now the lengths and widths can vary, but the acreage or the square footage cannot. So we're going to look at different ways that we can get 21,780 square foot lots. Right, so the two big questions we're going to look at is what function relates the length and width of rectangles with the area of 21,780. Most of us already have an idea of what that is. Area is equal to length times width, and we're going to explore those relationships between area, length, and width. And then what patterns appear in tables and graphs of that function. Okay, so let's look at these patterns. In part 1, we're going to go ahead and copy and complete the table. So what this is saying is, listen, you have a rectangle with an area of 24 square inches. When the length is 1, what is the width going to be? Well, in order to get an area of 24, right, remember, area is found by taking width times length. And so if your length is 1, your width is going to have to be 24. So it's going to have to be 1 times 24 is equal to 24. Okay, so we're going to answer all those questions. If the length is 2, what does the width have to be? All the way through 8. So go ahead and pause the video, do that, and come back. Go ahead and check your answers. When the length is 1, you should have an area or a width of 24. When the length is 2, it should be 12, 3 should be 8, 4 should be 6, 5. Now with 5, I have 24 fifths. Because if you have an area of 24, and you know that it's length times width, so 5 times W, and you have to think about, okay, how do I get W? What number times 5 gives me W? I know it's going to be a fraction or decimal. Well, ask the opposite question. 24 divided by 5 is what number? Right, and I don't even care what that is, right? It's 4 4/5 or 4.8, but 24 fifths is just as good. For right now, we can leave there because, again, we're exploring the relationships. We're exploring the story behind what happens with area, length, and width when we do different things to them, right? We're going to explore that relationship. So then when it's 6, it's 4, 7, 24 sevenths, or some equivalent mixed number or decimal. And then when it's 8, it's 3, right? The width is going to be 3. So those are from length being 1 through 8. Those are all the different possible widths. Now what we're going to do is we're going to take that table and we're going to plot it down here on this graph. And I'll help you get started. So for our lengths, you notice our lengths right here, they go from 1 to 8. So we're going to do the same thing. We're going to make this as 1, 2, 3, 4, 6, 7, 8. And then you notice for our widths, it goes from 3 to 24. So we're going to just go by threes. 3, 6, 9, 12, 15, 18, 21, 24. Okay, and then go ahead and plot this graph, this table, this data in the table above onto your graph. Pause the video, do that, and then come back. Okay, your plots should look something like this. Go ahead and check them against mine. And number 3 says describe the pattern of change. Describe the pattern of change in the width of the rectangle as the length increases. So reading from left to right on the x-axis, that's the length. So we are going this way. What is happening to the width? Right? So the width is decreasing. And it's not decreasing like up to this point we've studied a lot of linear relationships? Well, remember, linear means it's decreasing at a straight rate, or the line is straight. It's decreasing at a constant rate, but you notice that from 1 to 2, so when the length is 1 versus when the length of 2, the width goes from 24 to 12. And then it goes from 12 to, what was it, 8. 12 to 8. Now, the distance between 24 and 12 to 8, very different, right? So the change was huge, but now it's getting less and less and less and less. All right, so in your own words, answer number 3. Pause the video, answer number 3. And go ahead and try number 4, right? We've talked about fact families before in this class or the previous class. Think of all the different ways that you can write, I have it up here, the area equation, right? But instead of the 24 is equal to 5 times W, we're going to leave it as 24 is equal to length times width. So think of all the different ways. There's going to be 3 of them that you can write this equation, and I'm giving you one. That's length times width. 24 is equal to length times width. What are the 2 other ways? Pause the video, try that, and then come back. All right, so hopefully pause the video. I'm going to trust that you did. So the first way is to get W by itself. And so if we do that, you're going to divide by L, so that'd be 24 divided by the length. That gives you the width. Right, and that's exactly what we did up here. 24 divided by 5 gave us the width. But then also, if we wanted to solve for L, it would be 24 over W is equal to the length. Okay? So those are the 3 different ways to look at the relationships between area, length, and width. And that's what we're going to explore. On B is having you do the exact same thing that A parts 1 and 2 did, right? Except now it says you have a plot of land, so now consider rectangles with 32 square inches, okay? 32 square inches. So write an equation for the relationship between the width and the length, and we're going to write that relationship, and you can write it 3 different ways, just like up here. And then you're going to make a table and graph. Make a table and graph. And you're going from 1 to 10 inches for this. All right, so go ahead and do that, and then come back and see how you did. Okay, so let's take a look at the first one. Right up here, the equation is the area is equal to the length times width, but they tell us that the area is 32 square inches. So 32 is equal to length times width. Another way we could write that is with the equation solve for width, then the width is equal to 32 divided by the length. And then if it's solved for the length, it's the length is equal to 32 divided by the width. Okay, so that's the first one, writing the equations for the relationships between length, width, and area when the area is 32. Now down here, I'm going to go ahead and make out the table. Remember, you go from 1 to 10. And all of these, you can look up here. Now, we are looking to find the width, which is right here. So this is the equation that I used. So I just took 32 divided by this number. 32 divided by 1 gave me 32. 32 divided by 2 gave me 16. 32 divided by 3 gave me 32 thirds, or 10 and 2/3, and that's how I got all of these. Okay, and you can write them as their mixed number or decimal, but I don't want you using a calculator. You should know most of these decimals. You should know 2/5, 2/6, and 1/5, and 2/3 as well. But the 4/7 and the 5/9, not necessarily. Okay, so that's our table, and if you haven't made your graph yet, go ahead and pause the video and make your graph. Okay, so here's what our table should look like, and again, your length is in this case, your length is your independent, right? Because your width depends on your length. It could be the other way around. If I give you the widths, then your length would depend on your width. That's why we have the three different equations. So this is the one we're looking at where the width depends on the length, and this one is where the length would depend on the width. Okay. All right, so now looking down here, we can just draw a line of best fit, but however, our line of best fit is going to be different. I know this problem didn't ask you to do this, but you notice if we do the line of best fit, and we try to get it to go through the middle of those, you look at that and you notice that's not linear. That's not a straight line, and my line of best fit is actually terrible, but you get the idea, right? So that is our line of best fit, and part C says compare the tables, graphs, and rules for the functions relating widths and lengths of rectangles for the 24 and the 32 inches. Then use those results to answer the Roseville planners questions about lots with area of 21,780 square feet. So if you haven't answered part C already, taken into account of what do these equations, so what do these equations here, these are your equations, what do these tables and graphs, how do they compare to the ones that we did previously? And I'll run back to it here, right here. So how do they compare to this equation, this table, and this graph? So go ahead and answer part C right there. Pause the video, answer that, and then come back. Okay, now that you've had sufficient time to ask yourself this question, first of all, let's look at the equations. You notice let me go back here. For these, our equations up here, there we go. Our equations up here, there are different ways to write them. And we wrote the equation of 24 the exact same way. It's like you had 24 is equal to length times W. 24 divided by length is equal to W. 24 divided by W is equal to length. So even though it's a different problem, we can write them the same way. And so with that said, to answer this question with the plots and all the different options, well, listen, if you have a person that wants a plot length, right, to be, I don't know, let's say 700 feet, and we know that the area has to be 21,780 square feet, and we need to know the width, right? Well, we know that area divided by length is going to give us our width. So we're going to take the 21,780, divide that by our 700, and then that gives us our width of that particular plot. And it's easy. You could set up a table for all of the different options and lay that out to people like, hey, these are the options. If you want these lengths, this is what your width is going to be for your plot of land. What length and width best fits for what you want to do with your said plot of land. Okay, everybody's getting the same square footage. And your table is going to look very similar, because if they choose a length of 1, their width is going to be 21,780 feet in width, which is kind of crazy. You're probably not going to want to do that. There's not much you can build on that sort of plot. So you're probably not going to have anyone that wants to do that. And then also your table is going to look very similar in fashion, whereas again at 1 you're going to be all the way up here at 21,780 feet, but then eventually as it goes on, and like this would not be 10, this would be in the hundreds, right? Because if your length is hundreds versus ones, you're going to have a more usable plot of land, so it'll make more sense. But all of the patterns, all of the change is going to be very similar. And remember, what we're doing, we're learning this language that is mathematics. This language is all about patterns, is all about change and understanding those patterns and change so that we can better speak and understand this language. Okay, that's all that I had for this particular section. And this was from 3.1, Rectangles with Fixed Area.